To in course outcome 2, today's session we are going to see about the topic that is the factors affecting the motor performance. So, what are the factors that affect the motor performance are nearly 7 important factors that affect the motor performance. And first one, first important is the power supply quality that we have seen already in the last session also. And next one is the motor loading that reduces under loading. And third one is the sizing to variable load and the power factor correction. And fifth one is the maintenance of the motor. And sixth one is the aging. And seventh one is the rewinding effect. So these are the 7 important factors that are going to affect the motor performance. And regarding the first topic, that is the power supply quality. And power supply quality, how the power supply input power supply is going to affect the power supply quality, means the motor performance is affected. Surely the motor performance is affected by the quality of the input power. Actually, two important parameters are in power supply. Two important parameters, that is the voltage, actual voltage, and frequency available at the motor terminal. The incoming motor terminal, if the input voltage is not properly connected, or the full voltage is not obtained at the motor terminal. For example, if it is a single phase motor, means 230 supply, incoming supply should be obtained to the motor, then only it gives the full efficiency. So if the voltage reduces in the motor terminal, yeah, it's affect the motor performance in the output also. So in the input parameter, the motor terminal, if the voltage is affected, the output also the performance of the output performance of the motor also affected. And another one is the frequency in the motor terminal. If the frequency is affected, that is 50 hertz, 50 hertz, less than 50 hertz means gradually it goes on down. Automatically the output of the motor. And next one is the frequency. If the frequency of the input of the motor terminal changes, means the output of the motor also the motor performance is going to affect. And next one is the voltage unbalance across the 3 phases. If the voltage unbalance across the 3 phases of the input of the motor terminal occurs, means surely it is going to affect the motor performance. And the motor manufacturers in India, they are having a standard of Bureau of Indian Standards, that is the BIS. BIS have some tolerance in the input power quality. If the voltage variations of voltage in voltage variations, nearly plus or minus 6% of variation can be acceptable, as well as under the frequency variation. Regarding the frequency variation, plus or minus 3% can be accepted. So as per the BIS standard specify that a motor should be capable of delivering its rated output with a voltage variation of plus or minus 6% and the frequency variation of plus or minus 3%. And regarding the fluctuations in voltage and frequencies, when it goes very larger, quite common in unit supply, is quite common in the electricity of India, supplied in the electricity in India. So voltage fluctuations because surely going make a impact on the motor performance. And next, as we said before, the voltage unbalancing also create affect it's going to affect the motor performance. The conditions where the voltage in the 3 phase are not equal. If the voltages are not equal, that is the unbalanced in the 3 phase of the input supply, it is going to affect the surely it is going to affect the motor performance and the motor life also. And the next regarding the motor loading. Motor loading means the load percentage of the motor can be established by the following way. the percentage of the loading is calculated by the input power drawn by the motor, that is the kilowatt, by the full load nameplate ratings, kilowatt ratings into 100. By this we can calculate the percentage of loading. And other formula for the percentage loading is the input power drawn by the motor, kilowatt, at the existing load, by the power input drawn, that is the root 3 into kV into current I cos theta. By this also we can calculate the percentage of the motor loading. And if the motor runs under loading, if it runs under loading, means surely it is going to affect the performance of the motor. So care should be taken, and while choosing the size and rating of the motor, the load side calculation should be taken carefully, and ensure that most of the time the motor should not run with the underloading, because if the motor runs in underloading for a prolonged period, surely it is going to affect the motor performance. So when choosing the rating and sizing, the load calculation should be calculated, and the exact sizing and rating of motor should be chosen. So underloading results in the lower efficiency and power factors. It is going to affect the motor performance. So some other common several reasons for the underloading. One is that original equipment manufacturers should choose a larger safety factors in the motors when they select the motor ratings. So the underloading of the motor may also occurs under the utilization of the equipment, and as well as while selecting the large motors to maintain the output at a desired level, even when the input voltage are abnormally low. So the in underloading also may have effect while selecting the large motor for an application requiring the high starting torque. So a special motor should be designed for the high starting torque would have been suitable for this. And next, while choosing the sizing to variable load, the industrial motors should frequently operate under variable load conditions, and due to the process requirements. So a common practice is used in the case where such a variable loads are found while selecting the motors on the highest anticipating the load. And the alternate approach to this is the lesser cost while purchasing the motor, lesser cost and more efficient, and should provide. So in the choosing the sizing to variable load, then alternate approach to purchase the motor is we have to concentrate on the less costly and more efficient to give a satisfactory operation. And while choosing the rating of the motor, we have to calculate on the basis of the load duration curve for a particular application. And while selecting a motor of high rating also, that would operate a full capacity for only a short duration of period. If the motor is run at a particular load, then we can select the motor in a medium rating, just lower than that of the higher rating of the motor, because that type of if we choose that type of rating of motor can run at a full load of only a duration of short periods, and a motor rating would be selected slightly lower than that of the peak anticipated load, and would operate at overload for a short period of time also. And next thing we have to care should be taken, that is the thermal. The thermal withstand capacity of the motor should be considered while operating a higher load than the rated load. So when the motor run at a rated load for a prolonged period, there will not be any rise in the temperature. If higher loads, if it runs at a full load, that is a higher load, surely the temperature is going to rise. So the temperature rise in the higher load, that is the above the rated load. the heat raised by the insulations in the motor, it should withstand. It should have the withstand capability of the motor. So that should be considered here. And next is the power factor correction. So regarding the power factor correction, already we have discussed in the course outcome 1 also. We have discussed many things. So the power factor should less than unity. So but all induction motor are characterized by the power factor less than unity. So to lead the power factor, because by having the lagging less than the unity, surely the motor performance is going to affect. So for leading purpose, leading to lower overall efficiency and higher overall operating cost, will associate with the plant electrical system. So a capacitor should be connected in the motor as a shunt connection or parallel connection with the motor are typically used to improve the power factor performance. And some of the impact of the power factor corrections includes that it may reduces the kVA demand, it may reduces the I square R losses, it may reduces the voltage drop. If care should be taken for the improvement of the capacitors, and in the figure we have in the figure with the capacitor and without capacitors, in the figure have been ensured. Without capacitor, the power factor, without the capacitor, the power factor is low, and if we connect the capacitor is a parallel, in a parallel connection as shown in the figure, surely it is going to improve the motor efficiency. With the power factor improved and the overall efficiency of the plant also improved. Then next is the maintenance. So maintenance of the motor, maintenance should significantly increases the losses. If we take inadequate maintenance of the motor, surely it is going to increase the losses and leads to unreliable operations of the motor, as well as the industry. Industry is also going to affect by the inadequate maintenance of the motor. So for example, some improper lubricants can cause us a increased friction in both the motor and associates drives in the transmission equipments, that is the load side transmission equipments is nothing but it is the load side it is going to connect. And the resistance losses in the motor, what happens means the resistance losses will raise the temperature in the motor also. And some providing inadequate ventilations. A motor should have proper ventilations and cooling duct by frequently cleaning the motor. So this can dissipate the heat, and it reduces the excessive losses in the motor. And the life of the insulation of the motor will depend on the temperature only. So if we clean the motor frequently by maintaining the ventilation, providing the adequate ventilation to the motor, surely the temperature of the motor is not going to rise. How much of temperature is going to generate is how much of temperature is going to dissipate to the environment. Then the insulation will be the life of the insulation of the motor is protected. For every 10 degrees Celsius of the increase in motor, operate temperature over the recommended way. So the time before rewinding should be needed for X is estimated to be halved. And some of the maintenance, some of the checklist for good maintenance practice we have to maintain. One is that continuously inspecting the motor by regularly checking the wears and bearings of the motors, which can reduce the frictional losses. By having the inspecting the motor regularly, it is going to reduce the frictional losses. It is going to reduce the ventilation duct for dust in the motor, ventilating duct, and it should ensure a proper heat dissipation. So proper heat dissipation occurs means surely the motor temperature is not going to rise. And the checking load condition to ensure that the motor is not overloading or underloading. It should not underloading and not overloading. And you have to frequently check the lubrication wherever required. You have to check the lubrication property. And you have to ensure the supply wiring and the terminal boxes properly it is sized and installed. and continuously we have to inspect the connections regularly at the motor, and the starters of the motor should be sure that they are clean and tight, and checking periodically for proper alignment of the motor and the driving equipment. The improper alignment can cause the shaft and bearing to wear quickly and result in damaging to the motors and the driven equipments. And the next main topic is the aging of the motor. So most of the motor cores in India are manufacturing by the silicon steel and deharmonization cold steel. So the stator of the motor, that is the outer side of the motor, is not going to affect by the aging. Only the rotating part, that is the rotor, and the rotating windings are going to affect by the most of the rotating part of the motor is going to affect by the aging, and the electrical property of which don't change measurable with the aging also. So however, poor maintenance and inadequate lubricants of the bearings and insufficient cleaning of the air cooling process, etc., is going to affect the aging of the motor. So can cause a deterioration in the motor efficiency when it's run for a very overtime basis. And the humidity can impair the insulation property, and the mechanical stress due to the load cycle and to misalignments. However, the adequate maintenance and care should be taken to ensure that the motor performance can be maintained. And the next topic is the rewinding and the replacement issues in the motor. Generally, common practice in the industries is the rewinding or rewound the burnout motors. Most of the rewound motor in many industries, nearly 50% of the total population exists. What they are doing is, when the motor is burned out, they are going to just rewound instead of replacing of the new motor. Just they are going to rewound the motor. So carefully the rewinding should be taken. Sometimes maintaining the motor efficiency at the previous level itself. So carefully we have to rewind the motor, whether the motor efficiency is maintained in the previous level itself. But in most of the cases, the rewinding leads to reduction in the efficiency. It is affecting the efficiency. So rewinding can affect a number of factors that contribute to determination of the motor efficiency. First point, the winding and the slot design, and the winding materials, and the insulation performance, and the operating temperature. And some of the common problems that occurs during the rewindings are the heat is applied to the strip old winding, and the insulation between the laminations can be damaged, and leads to increases the eddy current losses, and a change in the air gap may affect the power factor and the output torque. So while rewinding the motor, these are some of the effect care should be taken in the effect of this motor, and a proper measurement are taken for the motor efficiency can be maintained after rewinding also. After rewinding, a proper measure should be taken, the previous level of before rewinding, the previous level of motor efficiency, and after rewinding the motor efficiency. So this can be data can be compared, can be kept and it should be compared, so that how the motor efficiency before winding and after winding can be confirmed. In some cases, after rewinding, if we check thoroughly regularly, in this means after rewinding the efficiency can be improved by changing the winding design. Only the efficiency of the motor is going to improve after rewinding. So however, in general, we are very strongly recommended that the all original design of the motors be preserved during the rewindings, and the impact of the rewindings of the motor efficiency and power factor can be easily assessed if the no load losses of the motor are known before and after the rewinding. And the reason for losses in the efficiency, reason for losses of efficiency in the rewound induction motor are due to the following factors. One is the eddy current losses. Eddy current losses happens by the varnish band or core becomes solid mass and some presence of carbon. How the presence of carbon happens means some left out carbon particles in the varnish bands. When the motor bands, if we go for the rewound means the some presence of carbon which is present in the present carbon particles are present during the banding time, and the quality of the copper for rewinding purpose, the quality of the copper, that is depends upon the cost wise rating. So variations from rupees 400 to 800 per kg. So during the rewinding, the quality of the copper also make reason for losses in the efficiency of the motor. And the unskilled labor is the main thing. The non technical manpower and not using proper instrument also affect. And the increase in overhaul position, these are the main reasons for the losses in the efficiency of the rewound induction motor. And rewound induction motor in common industries, for example the textile papers and floor mills, they have the excessive losses, and every rewinding of the motor is going to affect the performance of the motor by 0.5 to 1%. And the potential to save, potential to save is that 5 to 8% while replacing with the energy efficient motors. So instead of rewounding, what are the advantage in the energy efficient motors we are going to see. So now the energy saving opportunities with the energy, that is the EE motors, how the motor performance is better than that of the rewound motor and some standard motors. So regarding the EE motors is one which the design of the motor is have been improved or incorporated, especially to increase the operating efficiency over the motor of standard motor designs. And some design factors are improved, focusing on the reducing the instinctive motor losses. In standard losses, what are the drawbacks in instinctive motor losses? That is the fixed losses and variable losses. So that some care should be taken in the design of the E motors. In design aspects, they were improved. So the improvement includes the use of losses due to the silicon steel also in the design factor of the E motors are considered. So longer core, in the design aspects, a longer core have been designed to increase the active material. So by this, effective flux utilization is improved, and thicker wires are used to reduce the resistance level in the EE motors, and thinner laminations are used. Used to reduce the effective current losses, and smaller air gaps between the stator and rotor have been obtained in the EE motors. And the next one is the copper. Copper have been used instead of aluminum bars in the rotor. If we use in the standard, some of the standard motors, in the rotors they are using aluminum bars. So instead of using the aluminum bars, if we use copper, surely in EE motors the motor performance is going to improve. And next one is the superior bearings. The bearings of the EE motors are better than that of the standard motors, and have the ventilation purpose also. Good ventilation fans, smaller fans have been improved in the EE motors. So the energy efficient motors now available in India with efficiency of are typically have 3 to 4% higher than that of the standard motors. So as per the BIS, the EE motors are designed to operate without loss in efficiency at load between 75% to 100% of the rated capacity. So this may result in major benefits in varying the load applications. So with this, we stop the today's session. Thank you.